Okay. Bar graph. So we looked at the bar graph. So let's look at one more time. Bar graph is also known as a bar chart. It is also known as a Pareto diagram. Usually when you have a bar graph, right? Remember in my previous example, I had first Roosevelt and then Landon, right? But I could also switch the order, right? So if I switch the order, it will be in increasing order, right? If I keep the way I presented it, it was in decreasing order, right? The rectangles, the height of the rectangles was in decreasing order, right? So that decreasing order, when you put it in decreasing order, that's when you call it a Pareto diagram usually. Okay. But it is still a bar graph. And you use a bar graph for categorical variables. But there are sometimes some variables which are numerical variables, but they only have few values. Okay, let's for example, let's say how many hours during a working day does a student spend time on the internet, let's say. You study that. So, or let's say, in a lot of your instructor evaluations or course evaluations, you have this, you pick numbers like 1 to 5. How do you feel about this and this and this? You pick 1, 2, 3, 4, or 5, right? So even though they seem like numerical, right? Because there are only few, you can think of them as categorical variables. So for those data, you can also make a bar graph. Am I making sense? So if you have a variable, what I'm saying, if you have a quantitative variable, but it has only very few possible values. Let's say it has only 10 values, 10 possible values. Well, I can think of it as a categorical variable. Is that okay? If that's what I'm saying in the third line there. By the way, all my notes should be in Moodle right now. Did you guys visit? And I think they are in Moodle already. Another example, ADA, employment status. So you select a sample of size, say 500 adults in ADA to survey their employment status. The survey question will be, let's just say, are you employed? And the answer will be yes or no. Let's just keep things simple. And the survey result, right? The survey result will look like what? Will look like a bunch of Y's and no and N's, right? So the survey result will look like, adults number 1, 2, 3 up to 500. There are 500 adults that we are asking, and the answers will be like why, yes, no, yes, no, yes, 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 no, 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 whatever that is. So you're basically collecting. So your raw data looks like this, right? Am I making sense? Once you have selected 500 adults in whichever method was appropriate, and then you ask them questions and they answer to you, and for each adult you wrote down the answer, right? So your raw data looks like that, and you look at the raw data, it doesn't tell you anything, right? So that's why you want to organize, right? So how do you organize again? Once again here, well, you just make a frequency distribution table, which means that you remember in this case the variable is employment status. The variable employment status has two values, employed or unemployed, right? And so you count how many people answered yes for the employed category, right? And you count how many people said no. Remember the question was, are you employed? Yes or no, right? So for unemployed, you are counting how many people said no, right? So those are the frequencies of the two categories, right? And the total frequency will be 500. And then the relative frequencies will be 400 over 500, 100 over 500, right? So you got 80% said yes, employed, and 20% said no, unemployed, right? So that's a frequency distribution table again. Again, so you can see the need to organize, right? If you look at the raw data, right, pretty much tells you nothing, right? If you look at anybody who looks at it, could say nothing, right? But anybody who looks at it says a lot of things, right? So this is right away telling you 20% of the adults in Ada are unemployed. By the way, these are again cooked up numbers, so these are not the actual numbers. So don't take them as the situation of Ada, okay? So I don't know. I haven't, again, I was lazy to look up those numbers. But you can look up those numbers if you search on Google. I'm pretty sure things will come up. And once again, for this frequency table, you can graphically represent that. And so you can graphically represent that in two ways. You can, so for each category, you're going to have a bar or a rectangle, right? They have the same width. The height of each rectangle is the count of that category, or it could be the relative frequency of that category. So in this case, I picked the count. So for the employed category, I had the count was 400. For unemployed, I had the count to be 100. Notice that I have a gap between the two, but I don't have to have gaps, so I can connect them as well. Those gaps are not needed. So you can use this or this, doesn't matter. And you can also use relative frequency instead of just the count or frequency. So in this case, remember 80%. So 80 means 80% here. 80% employed and 20% unemployed, right? So you can also use relative frequencies. Are we, how much time is it? One more example here. So this is from a recent book by Emmanuel Saez and Thomas Piketty. They are both economists, and so again, one of the things that economists study is income inequality. So what they did here is they looked at average income. So the top 1/10 of 1%, top 1%, top 5%, top 10%, and the bottom 90%. And the average income in each group is given. So the average income, so on the vertical line I have average income, right? So the average income for the top 1/10 of 1% is about 6 million, I think. Is that right? Yeah, that's 6 million, right? So top 1% is, I think let's just say 1.3 million. Top 5% about, let's say 450,000. Top 10%, 295,000. About 300,000. Bottom 90% is 33,000. Now, you have to be careful how you're reading them, though. These are average income, right? That doesn't mean that bottom 90%, every single household is making only that much, right? Average means some people are making more than that, right? Some people making a little bit less than that, right? So we have to be careful. Don't think that everybody is making 33,000, right? Okay, so, and same thing goes here, right? Not everybody is making 6 million, right? So some people are making more than 6, some people are making less than 6, right? Same thing in all these numbers, okay? So be careful how you read them. Okay, so that should be enough for the bar graph and pie chart. So what I want to look at is now dot diagram. Anybody has any questions on the previous example?